Arsenic and its toxic properties have been known throughout recorded history. Arsenic trioxide, or white arsenic, has been used in more murders and assassinations than any other poison. However, it's not acute toxicity that's the important issue with water. It's you can't get enough arsenic. You can't get a toxic dose drinking water. It's chronic exposure. And this next slide shows a list of truly terrible diseases that are associated with drinking high arsenic water in a lot of third world countries. Probably the hardest hit is Bangladesh, where over 80% of the population, that's over 50 million people, drink water from tube wells, and these wells are problematic for arsenic exposure. The U.S. Environmental Protection Agency lowered its maximum contaminant level for arsenic from 50 micrograms per liter, or parts per billion, to 10 micrograms per liter in response to updated cancer risks. 10 parts per billion, by the way, is roughly equivalent to less than 2 tablespoons of water in an Olympic pool. That's a low concentration, but the risks are real. This is arsenic in central Illinois. Certainly not as high a concentration as Bangladesh or Vietnam or these places, but some of the concentrations in the untreated water are above even the old standard. This is for private wells. The previous one was for public water supplies. This is arsenic in the Tolono area, just south of here. The thing I want to point out is by the orange arrow. Maybe you can't see it in the back. There's a little green dot for a low concentration right next to a high concentration. We see this everywhere, very heterogeneous distribution. This is arsenic with depth in Tolono. There's a narrow range of depths where the highest concentrations are found. We'd like to go back there soon and check that out some more. Arsenic has an interesting relationship with other solutes, especially iron and organic carbon. These data are from Tazewell County, but you can find very similar plots from other parts of the world. The explanation for this is that arsenic is either sorbed or co-precipitated with thin iron oxide coatings on sand grains. When the coating gets dissolved, it releases the arsenic to the groundwater. This is associated with availability of organic matter. When the USEPA lowered its maximum contaminant level from 50 to 10 micrograms per liter, the number of Illinois water utilities with potential arsenic issues went up quite a bit. We studied some of these. One of the things we found was that as iron in the untreated water increased, the arsenic removal improved, although there is still a range for any given iron concentration. So there's a little room for tweaking. Here's an example. Danvers is just a few miles west of Bloomington Normal. The operator here was adding a water treatment chemical and getting erratic results for his arsenic removal. We replotted the data and found that it wasn't the water treatment chemical, it was just the filtration, the iron removal that was really limiting them. They were getting pretty close at some times. For private well owners, about the best option for arsenic removal is reverse osmosis. You can either rent from an outfit like Culligan, or you can buy your own. There are literally hundreds of these on the market. RO seems to do a good job, at least limited data from our public service lab at the water survey indicates that. However, the graph on the right, this is for Nevada, shows that it doesn't always work. I'd like to thank all of the people who've been involved with me in arsenic-related research over the years. One name that I left off here, Chuck Curtis, sorry about that, Chuck, and anybody else I've forgotten?